So today and tomorrow, not only are we getting crazy today by not going over homework yet, but we're going to talk about infinity and negative infinity. Okay? Not quite beyond. Okay? Now, do you remember when we talked about the instance when limits did not exist? There's 3 of them. Okay? Either we had that crazy, like we oscillated real quickly, okay, and you all like scribbled in your notebook, okay. We also had the one we've been talking about over and over, the left and right side don't match. But then what was that third case? Okay, where we're approaching, essentially, yes, okay, we're increasing or decreasing without bounds. Yes, those limits don't exist. However, now we are going to actually express them in some way. Okay? We are going to say that those non-existent limits are either infinity or negative infinity. So in this picture, our limit to the right of x equals 2 is positive infinity. And our limit to the left of x equals 2 is negative infinity. We can describe the behavior of our non-existent limit. So no longer do I want you to put D and E if we can describe it with an infinity or negative infinity. Sometimes we're still going to get D and E. That's fine. But if we can express it with infinity or negative infinity, that's what I want.
You need to put the plus sign in front of positive.
I'm just trying to make a point on those notes. But if you have just a normal infinity sign, I'll know what you mean. Okay, now somebody maybe already answered this question. Well, when is this going to occur when we have what on our graph? Okay, so we need to be able to identify our vertical asymptotes. We've kind of been practicing that a little bit with our discontinuities. Okay, but we need to understand that at a vertical asymptote, on the right side and on the left side, we could be approaching infinity or negative infinity. Okay? Now, look at that graph up there. If I asked you for the limit as x approaches 2, you would give me the answer of just normal 2. X approaches 2. It does not exist because the right and the left side are not matching up. Okay? Now, if they were both going the same direction, like let's say instead of this was happening, then we could say the limit as x approaches 2 is infinity because it's approaching infinity on both sides. Okay? But in this case, the limit as x approaches 2 doesn't exist. Okay? So, on the next screen, we are going to identify our vertical asymptotes. Okay? I need you to be able to look at a fraction and understand that you are evaluating the limit at an asymptote or you're evaluating the limit not at an asymptote. Okay? Because if you can identify right away that your limit is at an asymptote, you know that your answer is infinity or negative infinity. Okay? So, here are 3. I'm going to go ahead and only show you 2 of them. 1 minute at your table, identify for me the vertical asymptotes. Haley Mosley.
No, I'm gonna do
Some of my girlfriends have like passed down. One.
I can't remember between the which way we like calculate. We're gonna do terms.
Denominator.
This one you're gonna have a whole, but you're also gonna have an asymptote, right?
Raise your hand if you need more time. Thank you.
Yeah.
What time do you Okay. The band says saying Okay. I didn't know if you earlier. Okay. All right. Our first one. Max, where's our asymptote?
1. X equals.
Okay. So if we had this as our function, and I was asking you for the limit as x approaches 1, we would have to think about, okay, there's an asymptote there. Okay. What about j of x? Owen.
X equals -2.
Now that's not the only place that the denominator is 0. So what else is happening?
A whole at x equals 2.
Okay, there is a whole at x equals 2, which we can evaluate that limit, no problem. And you would simplify, right? Even before you do this limit, I would hope that you would simplify x minus 2 over x minus 2, x plus 2. You would simplify to 1 over x plus 2 before you evaluated this limit if it were at -2. Okay? Now, I decided we could do this one together. G of x equals the secant of x. What do you mean identify vertical asymptotes? What? Okay, we need to think about how this is the same thing as 1 over the cosine of x. And this is something that we talked about, 2 days ago, right? 1 over cosine of x. Or we talked about sine over cosine of x. But still, cosine of x in the denominator means we have vertical asymptotes at pi over 2. And it happens every pi. Okay, so before my cheerleaders leave, okay, write down f of x equals -1 over x minus 1. Write it down. Write it down. Okay. Now, I am worried about the limit as x approaches 1. What do we know is happening at x equals 1? There is a vertical asymptote. So before you say doesn't exist, first of all, we need to think about what's happening on the right and what's happening on the left. So let's take the limit as x approaches 1 from the left side and the limit as x approaches 1 from the left side. Okay. So we have a vertical asymptote at x equals 1. Now, we know that if we try direct substitution, It's not going to work because we're going to get -1 over 0. But this is what I want you to think about. You know that this is going to be approaching infinity or negative infinity because we have a vertical asymptote there. So we need to calculate which sort of infinity we're approaching. So let me ask you this. If I take values to the right of 1 and I plug them into our denominator, what sort of values would we have? Positive or negative? Okay. So as we approach 1, our denominator is approaching 0 with some negative values. And I know -0 doesn't exist, but it just helps me see what's happening. As we approach 0 in our denominator, we approach 0 with negative numbers. So we are approaching positive infinity because we have negative over negative. Yes.
Wait, but like for that one, we're doing like x is positive, right? Or like bigger than 1.
Yeah.
So like 2 minus 1.
Right. So why did you guys tell me negative?
Yeah, we were talking about like total.
You were talking about the whole thing.
Yeah.
Okay, so let's back up. In your denominator, x minus 1 would be positive numbers because we're to the right of 1. Which means your fraction is approaching negative numbers, okay? So we really have negative infinity. So as we approach 0 in our denominator, we approach 0 with positive numbers. So we have -1 over really itty-bitty small positive numbers. So we're heading to negative infinity. Now if we go this way, from the left side, we know we're getting -1 over 0. However, as we plug in numbers to the left of 1, we know our denominator will have negative numbers. So as we approach 0, we're approaching 0 with negative numbers. Positive infinity. Okay.
Good luck. Very technical.
Be peppy, be loud.
Go for it.
Okay. So before we go any further, do you have a question that you need to ask me? So then, if I asked you for the limit as x approaches 1, you would tell me does not exist because our behavior is opposite. We can identify the behavior of the right-hand limit. We can identify the behavior of the left-hand limit, but collectively, the limit as x approaches 1 would not exist since they're going different ways. I know the like 1 over 0 thing, it's kind of strange, okay? We gotta wrap our head around it, okay? So we're gonna do another one.
Okay. So, if they were both negative, both positive, then it would exist?
Yes. Could you wait like 3 minutes for us to get through this example, Brinley, and then we can talk about it all together? Brinley is ahead of the game here.
I was just confused.
If they're the same type of infinity, then you could identify it like that. Okay. So let's look at this one. So first of all, if my limit is at x equals 1, is that a problem spot?
Yes.
Yes, because we have a vertical asymptote there. If it's not a problem spot, direct substitution, you go. Okay? If it's a problem spot that you can algebraically get rid of, then do it. But if it's a vertical asymptote, there is nothing you can do. Okay? Which is why, like, we're getting that -1 over 0 in that first example. When you get 0 over 0, there's something algebraically you can do. When you're getting a number over 0, more than likely you have that vertical asymptote happening. Okay, so that can be kind of a checkpoint for you if you need to back up. So if you have a vertical asymptote, and I'm asking you for the limit, you need to think about the limit from both sides. Okay. Okay. So from the right side, if we use direct substitution, we're getting 1 over 0. Okay, 1 over 0. That's not good. All right. But as we approach 0, our denominator is getting really, really itty bitty. So our fraction is getting really, really huge. Right? 1 over really small numbers creates a very large number. Do we all understand that? Okay, so as we approach 0, our numbers get smaller and smaller and smaller and smaller and smaller. Our fraction gets bigger and bigger and bigger and bigger and bigger. Okay, now how do we approach that 0? If we were to plug in numbers to the right of 1, then x minus 1 squared would be what kind of numbers? Positive, not too difficult to think about because we're squaring, right? Doesn't really matter what's happening, they're going to be positive. So, as we approach 0, our denominator is approaching 0 with positive numbers. So, this fraction is getting bigger towards positive infinity. Okay, and some of you are already like a step ahead of me thinking about our left-hand limit. Okay, our left-hand limit, we still have 1 over 0. Now if we plug in numbers just to the left of 1, x minus 1 would be negative, but we're squaring it, right? So that turns those into positive. So again, we're getting a positive infinity. Okay, now this was Brinley's question. What happens if these match? Well, we can now say that the limit as x approaches 1 of this function is infinity because both the right and the left side have similar behaviors. Okay. What do you think about that? Isn't it? Okay, so here's what I worry about for you. Right now, you're going to do your homework and you'll be like, yeah, this is great. And then I mix these in with all of the other limits, and I worry about you identifying that it's one that has a vertical asymptote. So really be careful when you are thinking about these problems. Does it have a vertical asymptote? Does it not? Okay, before you start just mowing through this process. Because if it doesn't have a vertical asymptote, this isn't going to work for you. Okay? Or if it does have a vertical asymptote, stop, break it up to left and right hand limits if it's not already. Okay? All right. Write this one down. Okay, so this is a right-hand limit, okay? With direct substitution, we can see that we have 2 over the sine of 0 equals 0. Okay? So algebraically, there's nothing we can do, okay? We are talking about a right-hand limit, so let's think about as we approach 0 from the right. So the right side of 0 would be like pi over 4 and pi over 6 and pi over 8, blah, blah, blah. So coming from the right side of 0, what kind of values does the sine of x have? Positive. Good answer. So we're coming at 0 from the positive side. So I have 2 over really small numbers that are getting smaller and smaller and smaller and smaller and smaller, approaching 0. So we can identify that this fraction gets bigger and bigger and bigger and bigger and bigger towards positive infinity. Okay? It is not 2 over 0 equals infinity. It's 2 over approaching 0 is infinity. Okay, we are talking about limits, so we're approaching. Okay. I am going to give you, let's see. Don't write these down. These are in your book. I just want to talk about them. If the limit as x approaches c of f is infinity, and the limit as x approaches c of g is L, a number. Okay, so f is infinite, g is not. Then if we tried to add those two limits together, infinity plus a number, we can say that that's infinity. Okay. If we multiply infinity times a number that is not 0, we can multiply to be either positive or negative infinity depending on the value of L.
Teachers, at this time, please release band and color guard students to get ready for the pep rally. Again,
It's going to be one example that you guys are
at this time.
okay?
No pet.
There's no quiz tomorrow, right?
Are you kidding me? Of course
Is there a quiz?
It says 3.5 notes.
Yes, there's a quiz.
There's always a chance of a homework quiz, but there's no like quiz.
Gotta finish up.
Always a chance of a homework.
Always a chance.
Evie, would you like to come over here? You work for me.
Yeah, we can come over there.
We can get our notes on
No Titan sits alone. That's the Titan.
You have your homework.
Oh, yeah.
Yeah.
Okay, and then if we take our number limit divided by our infinite limit, goes to 0. Let's talk about that one. Our numerator stays. Our denominator gets bigger and bigger and bigger and bigger and bigger. What's happening to the fraction? Smaller and smaller and smaller and smaller and smaller towards 0. Yes.
What if you do like f of x over g of x?
Infinity. So infinity. Okay. All right. 2 graphs on the next slide. I'm going to have you draw them so that when you go back and look at this example, you know what the heck is going on. Okay, this is F, that's G. I think we've actually used these 2 graphs before. They may look familiar. So I think this was like our warm-up the other day. And I asked you to do some various things with them. Alex, did you get a haircut?
Yep.
It looks very nice. do we get?
Oh. That's it. What?
All right. We are going to look at first the limit as x approaches -1 from the left of f of x over g of x. Write it down. The limit as x approaches -1 from the left of f of x over g of x. As we approach -1 from the left of f, what are we approaching? Okay, here's x is -1. We're approaching y value -1. As we approach -1 from the left of g, what are we approaching? You are not writing does not exist. Okay, it's a left-hand limit. So we can describe how we are approaching 0. So from the left, we are approaching 0 with what values? We are underneath the x-axis, which means we have negative values as we get closer to 0. So we are approaching 0 with negative y values. So as our denominator approaches 0, our numbers are getting really, 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 really itty bitty, but on the negative side. So we have -1 over really, really, really itty bitty negative numbers. So our fraction goes to positive infinity. Courtney, do you have a question?
Huh?
Do you have a question?
Yeah.
Okay. I couldn't tell if that was a look of like satisfaction or confusion. So, or maybe out to lunch. Okay. Okay, next, that's not the color I want to look at the limit as x approaches -1 from the right of f of x over g of x. Now, as we approach -1 from the right on f, we still have a y value of -1. As we approach -1 from the right of g, we're still approaching 0. However, this time we are above the x-axis. Do you see that? So we are approaching 0 with what kind of values? Itty-bitty positive values. So we have -1 over, we are approaching 0 with positive values, so our entire fraction will go to negative infinity. All right, we have about 8 minutes left together. So let's get organized for our homework. And then if you had questions over last night's homework, we can address that right now. Okay, so let me stop this video. Thank you, Pep Rally people, for joining us.